Hello everyone, I'm Bhargav and I have Victor with me. We will be presenting Rib My Ride, or how we brought Uber driver app to Android Auto. So here's a quick agenda. We'll go through why we built it first, then what core features we supported, then we'll go over how we modified Uber existing architecture, and some high-level paradigms we'll be using or developing Android Auto, and some success factors that played pivotal role for Android integration. So you guys would be familiar with Rider app. So let's get a glimpse of what driver app looks like. So as you launch the driver app, on the first screen, you see the Go button, where you have to go online, and then you will be start receiving the trips. That's the second screen, where the driver can see the fare, pick up and drop off location. And as you accept the offer, you will go to you will be able to navigate in-app to the pickup location. You can start the trip, and you can navigate to drop-off location and end the trip. So this is just tip of iceberg, where when driver is online and on the road, he or she would be navigating through the last three screens most of the time, like offer, trip, and things. So why? So there are huge safety benefits. And we launched CarPlay before Android Auto, and we also see in-house like very huge improvements in safety metrics. And also, since inception of Uber, we only had one mobile surface, where, and it's small, right? Like, and with adoption of new tech with Android Auto that more vehicles are equipped with, we thought like, why not? And also drivers were demanding it, so we built it. So what core features we supported in Android Auto? So we could have like dumped in everything, but there are some constraints like timeline. We want to launch the first iteration, as well as some Android Auto library offerings that we wanted to see what Android Auto library has to offer. And after deep diving into what features would help drivers on bigger screen, we ended up going with this set of features where drivers can go online. There is a heat map that gives guidance to drivers where to drive to earn more, and offers, so you can interact with the offers, accept and decline. They can do in-app navigation, as well as do start trip, as well as complete trip.
So here I'm going to talk about how we modify our existing architecture to accommodate Android Auto. For everybody who's not familiar with how we work on Uber, our architecture is based on technology that we build we call RIPs. So basically, we are RIPs-based firm. All our applications are using the same architecture. RIPs is a framework with business logic as a first-class citizens and not just simple a view. So we can compare, with a Lego brick that we can move around as we need to. And here in the screen, we can see a simple diagram on how a RIP, how the RIP is basically the components of it. So we have the rotor interactor, which most of the business logic happen in the interactor. And we have a presenter which connects to the UI component. And maybe the question it is, okay, so there is no big difference between an interactor and a fragment, for example, or any class that handles business logic. So in Uber, we also see this, and we have something we call a worker. So basically, we attach some classes that helps manage the business state of an interactor, so it becomes less bloated. And also, it is attached to the same scope of the interactor. So in this case, if the RIP dies, our worker dies too. So what it means in the RIP world, well, basically, is one RIP can attach another RIPs. It creates and attaches, and it can grow until up to infinity. So infinity in this case, but we are aware that there are some limitations on memory. In a real world, we can see, for example, that on the left side, you will see the Uber application, how the users see it. And on the right side, we can see, the RIP tree. So basically, each part of this application is a different RIP, and each RIP handles their own state. So in this case, like the parent RIP, let's call it, root doesn't care about what their children are doing in this case. So pretty much. Another beauty of this is like, each component is maintained and it's owned by different teams. So we can all work in parallel. And also, for example, if a particular item needs to be moved, it can be easily moved without blocking other teams. And okay, so we have, with Android Auto, we have a new surface. The question here is like, okay, we have the rear architecture that it is working, pretty much for us. How about we just copy, paste whatever we have into, the solution that Google is presenting, and we call it a day, we ship it. And yeah, that's the ideal world, right? It's like that we don't need to write code at all. But in reality, it's like the car app library, it's quite limited. And there are some aspects on why they're doing that. It's like safety, let's call it, is like more important. So the way that it works, it's pretty simple. It's a simplification of the process. So when the user taps, on the head unit an application, the icon of your application, your main application will launch a car app service. The app service will spawn a session. The session is pretty much similar like an activity. If you think about it, it has, a life cycle. And the session, what it does is like it will launch your main screen. And from there, a main screen can attach more screens, in a stack aspect. But there is a huge limitation with the screen. It's like we cannot touch views. The screens can be only mutated by templates. And template is just a view model. So that's pretty much, so here our question was, okay, how can we convert the Riv architecture to work, with the Android for Car library, which we have different, the paradigm is totally different. And that's how we introducing here the car screen rips. So again, carrying the button of rips to Android Auto. We did a seamless integration with existing architecture, which also is easing the learning curve for Uber engineers. So we are familiar with rips. We know how it works. So pretty much we do the same, when we build this extension of the library. There are some limitations, of course. Screen rips are only responsible to present or handle data, on a single screen, which unlike, with view rips that you can attach multiple visual screens in a single node. So if we see the diagram again, it's like we can pretty much see here that it's pretty much the same. So the key components, the rotor interactor, stay the same. The only thing that we change is how we present the data. So that's the beauty of RIPS, is that it can be integrated with new technologies. So yeah, that's for me.
So let's go over some high-level design paradigms that we use for developing Android Auto. So first and foremost, consistent state between these two surfaces. It was no-go because we don't want to confuse drivers while they are on road. One says turn left, one says turn right. It would be disaster. So consistent state was the main thing, and it also influenced a ton of architecture decisions that we made. Avoiding duplication and redundancy. So specifically, driver app has long-running sessions, like multiple hours. So we don't, and it does thousands of API calls and data processing, and we don't want to do it twice. So we try to avoid as much as duplication redundancy as possible. Keeping things simple. So as Victor mentioned, we build car rips, but we need to build similar framework around to handle navigation and things as well. So keeping things simple was also a key part of this one. So like other feature engineers or other engineers can onboard to Android Auto and build features quickly. Future-proof app lifecycle. So we have an abstraction around app lifecycle, and one of the common abstraction is like foreground and background, where the app lifecycle sends foreground event if activity is in foreground and background when like activities in background. But it was not considering the new surface, that's like Android Auto surface. So, and also specifically where driver app relies on navigation and location, and also we do less processing when your app is in background. So what will happen if we don't do this change would be the Android Auto screen would be in very stale state, or very update could be slowly or have some lagginess in there. So we had to fix this first before moving forward. And we build it in a way where it can be extensible to multiple surfaces. So car app Android Auto head unit is one thing, and also there is a cluster unit in the car where we can also display the map and navigation. So that would be another surface. So when we develop it, we just need to hook it up with the current app lifecycle framework. Safe rollout. So especially for the driver, it's a bread and butter. We don't want any degradation to happen for a prolonged period of time. So for any unforeseen circumstances or feature breaks, we want to roll back immediately. So we had any code changes we made, it was 100% feature flagged. So let's deep dive into consistent state and redundancy. So on the screen, you see there's an activity, and below is the small version of rip tree, where root and active are viewless rip, so meaning it would stay alive when your app delegate just spins off. And active with activity is where the screen relies on. So when active with activity is attached, you will see the screen that you see right now. And when you connect to Android Auto, we attach the car active rib, and that's beneath active. So whatever state active or processing active does, we just consume it on car active. We don't do duplicate processing. So these two things goes hand in hand. If you have same data source or same data processor, you can rarely go out of a state or out of consistency. And also, you don't have to like redo all the processing that active does it. Let's take another. So when even like the activity gets destroyed, like driver just kills the app or something, the rip tree stays there. We need all the data to be processed still because Android Auto surface is there. So here's another example. When you request, when there's a trip request, you see the dispatch rib is still a viewless rib. So it does all the processing over there. What we consume is the UI part and the data part. And also the interactions are being processed at the viewless rib, that is the dispatch rib. So we don't even have to maintain the state of like if one surface you hit accept and the other surface should go away right away. So let's go with keeping things simple. So here's a typical screen implementation where you want to log impression for observability, where we should know that what drivers are seeing. Other is like relay and updates to update the state, meaning you want to update the routing card or the picking up tail and like the name, you need some updates. And the catch here was like you need to call invalidate in the framework every time when you do any update. So if you forget to call invalidate, the state will be stale and you won't be able to see any update. And you want some interactions to handle, so you need to relay the actions that your user is taking on the screen. So we extended the existing screen into Uber car screen, and what we get for free is logging impression. Then the consumer just need to pass the unique identifier, and it will log implicitly. So they don't need to worry about whether my screen was in foreground or something. As soon as it goes foreground, we log the impression. And we have a dedicated API to relay the state and relay the events. So they don't even worry about the contracts, and we have a control over what state the screen is in, and no worry about the invalid call. So that's how it was like easy to use, and they can just onboard to it right away. So next is screen stack API. Since we have rips, we have our own screen stack to navigate between rips, meaning like when you want to go to a new screen, the push screen is the one, and when you want to go to previous screen, pop is the API that you use. So we have built a similar API, exactly the same API. The behavior still says have the same, where the push screen will do new screen and pop will go back to your previous screen. And some optimization APIs. So we have some workers that don't need to run, like when, for example, like when app is in foreground, you need to run some workers, but as long as app goes in background, we just want to stop executing. We don't want to create any extra pressure on the app or don't want to do any additional processing. So we came up with the conditional worker API that will only run when the certain conditions are met, and it will stop right away. So here's the example where we want to run some workers when a surface is alive. So right now you see the activity is alive. So the conditional workers are running and do its own thing. As soon as it goes off, the workers will stop. And when they connect to Android Auto, the workers will start resuming. So here we are not doing any extra processing when it is not needed. Versus if this API was not there, then consumers can easily attach their workers to active, and it will stay running irrespective like whether your activity or car is connected or not. So let's go over some factors that played pivotal role in the success. So first is not reinventing the wheel. Rips, where we evaluated rips that were like feasibly scalable to Android Auto use case. So sticking to that, was like flat learning curve for engineers to onboard to it and build features on top of it, versus like ramping up on the new model that we align on and things. It just takes some time and to ramp up. The next is relying on single data source. So consistency was the key part, so relying on the data source was also the key part for consistent state. For the next three, let's dig into details. Abstraction and modularization. So RIB itself is an abstraction where you can move around, right? So as you see here, the map RIB, that's a single map RIB, just the two instances of one is attached to activity and one is attached to Android Auto unit. So we did some configuration changes, but apart from that, it was right out of the box, easy to use. So this was the one of the example, but we have used multiple similar cases for navigation or the guidance heat map that we showed before. So that's how we boosted our velocity as well, and we can ship it out quicker. Single response principle. So we have 50 plus workers where we have to move around to support this Android Auto use case. It was fine till we came across like some of them that were like very versatile. They had to do everything. They had to do API call. They had to interact with the UI. They had to like send alerts and things. So it was not possible for us to like just reuse it right away because it will result into duplication and things. So we had to break it down and do the right thing to make sure there was no duplication around.
So another factor that really helped us to release this product is early exploration. So again, as we explained earlier, is like we look around the feasibility between the ribs and the screen. So for example, it won't help, that trying to embed everything that we have if there is no compatibility on the screen. We also build like early proof of concepts just for learning and discovery. It's something hacky, it was ugly, but it worked. So with this, what we also accomplish is like we check the current templates and APIs, what it offers, and it makes sense because the cars library is quite limiting. So we need to find out like a sweet spot on what we can implement or not. One motto that we follow is make it work, then make it prettier. It's better, to check that our code base or the ideas that we have was working, and from there we just, make it better and better. And also, whatever we found out is like we flag it early to the Google team. So by the time that we are almost finished with the product, that improvements are there. And it was a never-ending cycle. It's like we did refinements of our ideas. So some big wins that we have here, we are seeing 24.2% of adoptions among the compatible users, right? We are seeing 71% of retention. So it's pretty, big for us. And also we are seeing lately issue-free session, which is important, right? So they're working for several hours, and we don't want, the application to start crashing randomly. And I believe the huge, as an engineer, was that we didn't have any big outage incident post-rollout, which is really important as when you're part of the on-call rooster, right? It's like, we don't want, to be dealing with this. That's it. That's it for us. That's pretty much how we bring the application. So any question, please let us know and come and say hi to the booth. Thank you.